Okay, I think the recording is in place now.
Okay, very good. Very good.
Okay, and
Well,
our flyer of record is here yet,
yeah.
I think. Um, wait, okay, so right here we have our fully assembled, but can we have a camera according to that?
Okay.
Wait a minute. Sorry, get a camera running.
Oh, I see it.
Okay.
I can see
Yeah.
parts of it. Yeah, very good.
Okay.
Well,
So
let me just start by saying that I'm honored to be with your team and to work with you on this. I've looked at your work. You do excellent work. You have great leadership. You have obviously very bright students, and I'm just delighted to do this. So thank you for letting me participate.
thank you very much. We are so very delighted to have you as our safety reviewer too.
Yes, indeed.
Okay. So can you see our like kind of assembled but disassembled rocket?
Right. I can see a nose cone, it looks like, and um, body tube
Yep.
over
So
there.
from the left to the right is the from the nose cone
Right,
to,
right.
and we have
Oh,
each
oh, better
frame.
close up. Very
Yeah.
good.
Okay. So, and then we have each frame, and then in each frame we have all of the connected parts outside right there, lying around. We will go into details later on if you want to.
Okay,
And
that is excellent.
yeah, and to the right of it is the end of the rocket, the fins.
Oh, oh, pretty fins.
Yeah.
And your
Okay.
number. Hey, the number's there.
Yes. And also just a quick shout out. These rockets
Yes.
are actually like having like a lot of the spare parts because some of the actual parts we are have already sent it to America because we need to like ship
Oh,
it there. So it's take quite a bit of time. So we need to like plan ahead quite a bit.
right.
And we have already dynamic tests like a flight test
Hmm.
uh
Hmm.
to a rocket. So and we have another planned test incoming too. So we don't have like
Okay.
the real equipment that we use to test here. This is just some of the spare parts.
Oh, yes. Okay, that's fine.
Yeah, but it's like completely identical to the real one.
Okay, good.
Okay,
What is
so
beautiful?
thank you very much. Okay, so let's get on with the review.
Okay.
Uh,
Did you wish to make a presentation to me, or should I start with questions, or where would you like to start?
uh, which way would be better for you? Like,
Well, if you have a presentation ready, I'd love to see it because you may answer many of my questions. But I can go either way.
I think we should go. I think it would be better if we go with questions first.
Okay, well, I sent a few in email. I don't know if you have had a chance to see it, but they were largely about the deployment recovery.
Okay.
And one was I was looking at your the piston you were talking about, and I didn't quite understand where it was or how it would move. Can you show me what the piston's like and
Oh, okay,
how
sure.
it will be actuated and what it will do?
Right. Okay. So right here is so right here is our actual piston. This
Okay.
right here. Although there's no
Okay.
like kind of the radial bolt thing that I talked about in the technical report.
Oh,
As
yes.
the actual part would have radial bolt, like these holes right here. We would have these holes. The frames would be on here, but for the spare parts, we didn't actually uh made the hole because it would need to fit into a carbon frame, and we don't want it to be like specific for a frame only as it's spare parts. So we
Okay.
haven't
Yes.
actually punctured it yet. And this piston is in the top frame, as you can see right here. It
Okay.
would
Yes.
operate by these charge case that I talk about in the technical report too.
Yes.
Uh, so these charge case will have around 8 grams of black powder into loaded in the charge case, and after it reach an apogee, our board right here would have the wires connected into the igniter in the charge case, And after reaching an apogee, the piston would then actuate, and the igniter in the charge carrier would be actuated, which would subsequently push this. Give me a moment. Subsequently push down this our piston down onto the coupler, which would then push the top frame out of the main body frame.
Okay, so is that your separation point where you just pointed?
Yes, it would be right here. So
Right
if
here?
it was on the actual frame, it would be right around here. It would push the top frame
Okay.
completely off the main body,
Okay,
and there would the shock cord or the main cord going to this part would be slings, and then on the two ends would be our main shock cord connected to an eyeball, close to that eyeball.
okay.
And on the other
Oh,
end would
yes.
be a quick link onto our sling.
Okay.
Would that answer some of your questions?
Yes, where will the parachutes be?
The parachutes would be located right in this, right here, in this frame.
Okay.
So it
good.
would be, if we would look into the rocket, would be right around somewhere around here, above the flight computer, above the avionic, and
Mhm.
in the coupler right here.
Okay. Okay, that looks good. Another question I had though was about your main parachute. It'll be held in the rocket by a tender descender, right?
Yes.
How far inside your rocket tube will it be held?
I think gonna have my parachute guy answer that.
Inside,
Yeah.
it located around here on the top of
Okay.
the avionic part. Yeah, around here. The sender will, oh sorry, will locate at this part. And the main parachute will like inside the airframe when the
Okay.
door parachute is deployed.
Yes. Excellent. What I was concerned about is sometimes Rocketeers allow the main parachute to exit the tube and it's dangling in the breeze and flopping around. And quite often they open prematurely when allowed to do that. So I'm very glad yours will be retained inside the body tube during drogue recovery.
Yeah, that like the same concern that our mentor told us. So yeah,
Yes.
I think it's
Sounds like you have a very good mentor, a couple of them.
Thank you very much.
I guess that was a chuckle of agreement, right?
Absolutely.
Yes. Okay. Good. See, what are my others? Maybe I should pull up my email and remind myself. Oh, are you going to have more than one black powder charge for your drogue deployment, or just that one?
in tender, the sender,
Oh,
right?
no, it's in the piston, right? The drogue deployment.
Okay.
So within the drogue deployment, we are planning to have only one black powder charge, but within
Okay.
the black powder charge, we already have a two igniter redundancy system that would run into both the COTS and SRAD flight computer boards.
Okay, good. That's what I wanted to hear, that you'd have two igniters in that one charge of black powder.
Yeah, no problem.
Okay, and something else that you're almost certainly doing, I assume you're having complete redundancy between your COT system and your SRAD system, like separate batteries, separate switches, separate wires, separate everything. Is that correct?
Yes. Okay. Yes, the two flight computer, both COT and SLAD one, are electrically isolated.
Right, right. Okay, because everything must be completely separate. So if any one component in a system failed, the other one would save the bacon. So that's good.
Yeah, it's like
Now, something to consider. Oh, look, what a handsome guy on that computer wearing an Ezra shirt. There he is. Oh. Is a lot of Rocketeers will have two separate deployment charges. And that way, if one fails, the other might do it. And quite often they'll make the second charge a little bit larger than the first. So if for some reason the first charge was not adequate, perhaps the second one would be. But that's not a have to. What you're doing there is perfectly fine and legal. We can go with it if you like.
okay. We'll take that into considerations.
Yeah, yeah. Besides, you get a second pop usually, and it often helps locate the rocket at apogee. Well, you can see in here the second pop of the container.
Yeah.
And by the way, I really like that you're printing your charge containers, especially because you can make them as strong or as weak as you like. That's a
Yeah,
very, very clever idea. Thank you for it. I'm going to use that.
no problem at all.
You won't charge me for that one?
Uh, hopefully so, maybe. I'm just kidding.
Okay, a little bit, a little bit. See, was there
Uh,
anything else? Oh,
yeah, okay, you can go on with the questions. Next question.
um, there was one about the Atwood battle cord. I wasn't real clear on what that was. Is that like a heavy duty paracord?
Let me go grab my team, go grab some examples real quick.
Okay, yes.
This one, okay.
Oh, okay. Battle cord. Yes, strand
Yeah,
cord.
it's just
Yeah.
like a name. It's, I
Okay.
think it's like the same material with the paracord.
Yes, we have that here. It's good stuff. Now that looks like it's, oh, it's in pounds. Okay, that's why the number's bigger. Okay. Well, that looks adequate. A lot of people prefer the flat braided cord, the
Mhm.
tubular nylon, they call it, and partly because it doesn't tangle as readily, and also because if you suffer a high-speed deployment, it doesn't zipper your rocket tube as easily. I've seen round cords cut right through a body tube, whereas flat cords don't usually do that.
Yeah,
But
that's
what
like
do you have? What you have there is adequate. It would work.
okay.
But one thing to consider is if you come to the launch and whoever does your final review has a problem with that cord, it's easy to buy more. And you can easily trade that for a flat cord if they insist upon it.
Yeah, we have our mentors also concerned about this, and we want to ask you if right, I think it's right here. This right here, as they are concerned, have the same concern as you, as the round cord may be cut off by the frame. Would like having
Oh,
what is it called, a plastic tube around the round cord, would
right.
that be helping the uh
I'm
yeah.
sure that would help because when I've seen cords like that get cut, it's generally because they abrade against the sharp edge of the rocket tube. Because when a rocket falls, it doesn't just fall, it goes round and round and in all kinds of directions, and that cord is going to get rubbed against the edge of the mouth of the tube wherever it happens to rub. So yes, if you can place something like that at that point, I'm sure that would help.
Thank you very much for the
That might be
feedback.
another advantage for the flat tube. I'm not really sure.
The flat tube you're talking about is
Yes,
this one,
something
right?
like that. Now
Okay.
that doesn't look like tubular. It's hard to tell. They call it tubular because it's made as a tube, but then it's squished flat. So if you can go to an end and you can open it up where it's round, then it's tubular nylon, and that they tend to be favored. That looks very adequate though.
Okay. So yeah, we will also take this into further considerations
Okay.
after this meeting. Any let's move on to the next question you have.
Okay, well, can read my
Concerns?
notes. There was one spot, it's on page 19 of your document, where I think you got the terms cruciform and spherical interchanged.
Let me check the technical report real quick.
Yeah, it's on the paragraph that starts with to parachute, and it's the last couple of lines in it. Let me find it. I had it here just a minute ago. Okay, there's, oops, wrong document. Another wrong document. Where are we? Oh, there it is. Okay. So page 19. Zooming down to it.
Mission acoustic power present circular parachute. เราแชร์ให้เขาดูเลยเนี่ย
Are you finding it okay?
Yeah, we are trying to locate it.
'Cause I have it on my screen and could share if that would
Um,
work for you.
Yeah, okay, that would work for us too.
Let's see if this will let me share. Okay, I think it's allowing me to share. So
Yeah,
here we
we
have
can.
art. See it okay? I'll
Yeah,
make
yeah.
it bigger. Can I make it bigger? I'll try it again. A little bigger. Okay, under 2 parachute, this very last line is a tip off, I think, says, therefore, the team decided to use a cruciform parachute shape for both the drogue and the main. And yet your main rationale up here was that the
Yes.
the other one would have been better.
Yeah, yeah, okay, we mix it up.
Okay, that just want to be clear on that.
Yeah, we're using a circular.
Yeah, I'm
Not
okay with
sure.
whatever shape you want to use is fine with me, but I do agree that the spherical would probably better for what you're doing.
Yep, okay, yeah. That was a typo.
Although the cruciform looks so nice in the sky.
Okay, we think so too, but okay.
Anyway,
Yeah.
by the way, I like your parachute colors. They should be highly visible, both in the air and on the ground, which is another important thing.
Hopefully.
Okay, I'm gonna unshare so you'll have it all back here.
Okay.
Let me see, any other questions? Oh, about your telemetry, sending back data. Is that one that's gonna require a ham license? Or is it in one of those categories that does not?
So we use a 900 megahertz LoRa, which is the hardware capable of 1 watt, but I think
Okay,
we can limit in the software to less than 200 milliwatt.
okay.
So that
So you,
I think that wouldn't require ham, I think.
okay. I haven't read your documents very thoroughly there, but I'll look at them again and make sure. Another question, have you found a flyer of record yet?
Yeah,
Oh yeah. He's here with us right now.
yeah.
I didn't quite
Okay.
understand.
He's in here with us right now. We have already found a flyer of record right there. He's
Okay.
I'm here.
Very good.
Yeah.
Good. I was gonna volunteer, but you probably got a better one. But see, I couldn't do it until the safety reviews were over and you were all approved. Then I could volunteer for it. So I'm glad you've already got one.
Okay. Alright. Would you have any further questions?
Let me look over my notes
Questions?
here. Material.
No.
Oh, there was a material, a spot in your nose cone, a coupler that was made of a 3D printed material.
Okay.
And I just wondered what part was that? It wasn't obvious to me in the description.
So there is a part of the coupler for the nose cone.
Okay.
This one is already fully assembled, so I'm explaining on the further detail. So this is a aluminum part where the
Right.
force will be transferred to. So I made another 3D printed right here for just a coupling part because
Okay.
it does not have any force to actuate. It's just gonna
Hold two
hold two parts together.
Perhaps you could see into it.
Perhaps. I don't think so.
Okay, is it a plastic sleeve that goes inside
Yes.
the tubes?
Yeah.
My concern is if it's something that's going to be required to take a lot of stress or would be at risk if it distorted in the heat. That's something that would not be looked upon favorably in the final review. So just a question to answer. If it's something that it wouldn't matter if it distorted some, then it's fine.
So the material is made out of, we use the ABS plastic, so I think the
ABS?
heat wouldn't
Okay.
affect much on them.
Okay, well that's better. That
And
might
for the force, the nose cone tip and the shoulder and this aluminum coupler will be attached together using the stud, the long
that's
metal
right.
stud. So it will not affect on the force on that.
Okay,
And the
good,
force
good.
will be transferred to this little shoulder, aluminum shoulder, and to
Okay,
the whole
good.
thing. So I think it will be strong now.
Yes, looks like you have a very sturdy design. I like that.
And this one is the one that from the dynam from the flight test that we are for the real flight test.
Yes, very
So-
good. I was pleased to see you put a lot of effort and thought into your materials and how they went together. That's very impressive. And also, I love the step nose cone. That is an interesting idea. I've never seen that
So-
before.
So this one will increase more drag in.
Right, right. Okay, excellent.
So yeah, when we're talking about that, I want to mention some further updates. If you have
Okay.
noticed that in the
Yeah.
technical reports on the aero control system, we have
Yes,
talked about our airbag system, which was initially included into our whole system, but as we have written in the project report, as we have went into further researching and production and testing of the airbag system, the results were not quite as we expected. Yeah, it's not what we would expected. So, and our
Okay.
mentor recommend us to like put a drag ring onto the nose cone as a passive drag control so that we don't have to use an air brake to reduce the altitude because it is much safer. We don't have an active control to that. So there's less safety concern here. Yeah,
Okay.
so on that, we think we putting a kind of a dead weight into the air brake system instead, something similar to this, where it would just hold the real weight of the air brake system instead. And as you can see on the nose cone, we would have something similar to a nose cone, similar to that as a drag ring to increase the drag as a passive control instead of an air brake active control system.
Yes.
Would there be any problem with that or?
And no, I see no problem with that. I believe that's fine.
Okay. Do we have any further updates? No. Any more updates that we need to?
So we have one more question about the pyrotechnic wiring diagram. So
Okay.
this is
Wait.
มันจะกลัวปะวะให้พี่ถ่ายมาแล้วนี่ So this is our this is our ignition state wiring diagram. So let me go to each one. This is our advanced flight controller. This is our advanced flight controller. Can you see it?
Hardly, no, not well at all.
So the main question is, do I need our ATM right now is for the script. It is for the script. Do we need the shunt wire?
Okay,
So they should be in the method stage.
okay.
Like, do we really need it if we already have the skill switch to cut off the circuit to the script?
Okay, I'm not understanding this well at all. So here's a suggestion. We could do this offline, write up this issue and send it to me. And that way I can study it a little better. And see I can please your photos because I can't see them at all at this point. I don't really know what you're talking about. So it'd be okay to do this by email?
That will be fine.
Yeah, that will be fine.
Okay, good, good. And I won't write up any report on this until we've worked this out and figured it out.
Okay.
Okay.
Okay, so one more thing about the tender descender. It's the TD2 that we have some questions about.
Okay.
Is the TD2 recommended to use?
Mhm.
Because like, as in the page, it's still like
Experimental.
yeah, experimental, and we want your feedback on it.
Yes.
Like, would the TD2 be effective to use? Like, okay.
Oh, is that what you have, the TD2, or is that one of the originals?
Could you question that again? Could I have that question again?
Well, I'm not sure I understand the question. Do you have the CD2?
Oh yeah,
Or
we have
do-
the TD2 right here.
Okay, but you have another one installed right now, right?
Okay.
In other words, is
Um,
that one on your rocket right now?
No,
Yeah,
this
yeah,
one
yeah.
is the TD2 one.
Okay,
So our question is that, is it okay since in the rules does not mention it because I think it's just released on
okay.
the market. So will it be okay to use this one?
I believe so. Let me double check that.
It is the same. It is the same one with the L2 and L3. It's a Tinder Rocket 3 one.
Right. I'll run this by the other judges and see what the consensus is, because I'm not familiar with that model. And I've not seen anything about it yet, but I'll do some research for you.
Thank you very much.
Yeah.
Oh, and on the website, the original tender descender, the L2 and L3 model were out of stock, so we couldn't find it. So we decided,
Okay.
so we changed to use the new one instead.
Oh, okay, good. You beat me to it.
Okay. Okay. I think that will be all from our side of the updates. We have some pictures from our last flight test. And
Oh,
would you like to
yes.
see that?
Oh, yes, I like pictures.
Let me share the screen for
I
you.
like your videos too. Thanks for those motor videos. That does my heart good.
Thank you.
I haven't made a sugar motor in years and I miss it.
So here's our rocket from the
Ooh, lots of
26th.
smoke.
Yeah.
Yep. Beautiful.
Yeah.
Whee! Now, is that on your full size motor?
Yes, we launched it at full scale.
Excellent.
Yeah.
So your rocket is flight tested.
Yes.
Excellent.
And here's our launch rail and the rail button attachment.
Ah, and how the rail
It's
button
sturdy.
hold up?
It is very sturdy for the three aluminum rail buttons
Okay.
right around here. Yeah, they
Okay. Oh, right, those,
It's
you
not
made
great.
those from aluminum, but you also have the printed ones. Are they on this rocket too?
Oh, they are not on this rocket just yet.
Oh, okay.
We
I look
will
forward to
test
seeing
it
how
in.
that works.
Oh yeah, I would like that too, and we will test it on the next flight test.
Very good.
And
Wow. I love that column of smoke. Do you ever put titanium in your propellant?
not yet.
It gives a
What
nice
what
sparkle.
Oh, for a sparkle effect.
It's all cosmetic. It's just a fireworks thing, but I like it.
Yes.
yeah,
And
these
here's
are
our assembly process right at
Yep.
the field.
Ah, yes.
Yeah, the last test we used the original tender descender model right here.
Oh, yes. Okay. Do you still have that one?
We have not recovered our rocket yet because our first flight test we did not put the GPS tracker in it, but it is lost in the forest.
Oh, okay.
Yeah. Yeah. So that would be all from us. Oh, we also have the video.
A movie.
Yeah, here is it. Can you see it? Yeah.
Yes, I can.
ปลูกเขาจะแต่ง
Whoa. Beautiful flight.
Yeah.
Yeah.
Thank you.
excited to see that too.
Mhm.
Yes, and I think that would be all from us. Do you have any further concerns, questions?
Not at this point. Y'all are doing beautiful work. I'm very proud to be working with you and look forward to resolve these last two little issues, and I'll write a glowing report for you.
Thank you very much.
Thank you.
The honor is ours too.
Okay. Well, I very much look forward to seeing you in just a few weeks in New Mexico. When will you be coming in? Will you be coming in early?
Yeah, we'll be coming in quite early because we need to go get our shipped items and get everything's all
Oh.
sorted out first. Yeah.
Yes. Yeah. Okay.
Yeah. We'll be quite happy to meet you too. We're looking forward to that.
I look forward to it as well. You're wonderful. Thank you so much for letting me
Okay.
party with you. Oh, here, a little bit of Florida for you. But
Oh, so bright out there.
yes, right. It's nice now. It'll be way too hot in a few more weeks, but it's all right.
Okay. We look forward to that too.
Yeah.
Okay. Yeah, I think that's all from us. Right.
Alrighty.
Okay.
Okay. Well, I hope you have a good day, good evenings, good rocketry.
Okay.
Thank you
Hey.
again. This is lovely.
Okay.
Ready for bye-bye?
Yep. Okay. Thank you.
Bye-bye.
Bye-bye. Thank you too.
สวัสดีครับ see you to our Friday on record. Bye bye. So yeah, okay, let's get to it.
Okay. What the officers wanted me to do was to look at the various parts of your rocket just to make sure they looked like they were flight worthy. Now, you've flown this rocket before, I take it. Is that correct? Yeah, so it seems like it likely is flight worthy, but let me look at it anyway, if you don't mind.
Okay, so I'm going to switch my camera now.
Yeah,
So
we have-
again, we have our nose cone right here. This one is painted
Yes,
different from the last one.
right.
Okay, and that is our first frame, our forward frame.
Okay,
The-
yes.
Inside, we have our this one is as a dummy. The real one is
Okay,
our payload. This one is a dummy, but the real one is like for the planned flight test, which is we don't have that available. Sorry for that.
that's okay.
This one is our piston that you have seen last time, if you remember.
Right, right.
Yep. And this one is just a spacer for like just spacing these two.
Okay, very good.
And then that would be kind of all for our forward frame. The piston, as you can see, will be locked to our carbon fiber mounting right here.
Right, with lots
Then-
of screws.
Yep. We had
Yes,
to leave this, and then we move on to our couplers. This one, the couplers will be attached right here on that right there between these two
Okay.
frames.
yes.
And before we go further, we will have our this is our drogue parachute and then our main parachute
Right,
before between our piston and our flight computer avionics, somewhere around in the
okay,
coupler's middle frame right here, as we have said.
okay.
Yep. And then our avionics is being worked on a little bit, so
Oh, yes.
so
Okay.
they're doing some testing and stuff before launch.
Yes. Let's see.
So,
Now, let me ask about the batteries. I see a
Okay.
bunch of batteries there, a row of 4 of them.
this one,
Yeah, how are those secured? Are those locked in with, I can see the zip tie, but do you have something forward and back to keep them from moving up and down?
They 3D printed a lot to keep them from moving up and down. And
Oh, okay.
for the monitor- Okay.
Thank you. I can see that now. I just could not see that from the distance. Yeah, that's very good. Thank you.
I think that would be all for the flight computers.
Looks good.
And back here, we have if you recall last time that we talked about the air brake stuff, this is the
Right,
gateway that
right.
we're putting into
Okay,
the middle frame right here. And right here we have a service hole for our avionics, which will be covered once the avionics is put in, we will have a cover to cover the hole.
okay, good.
Yeah, this is the example of the cover plate.
Oh, okay,
It'll be locked in with screws.
okay,
Yep. And then that would be the end of our middle frame or interframe. Moving
okay,
on,
good.
we have also the same coupler,
Yeah.
which will be locked on to both of this frame right here.
Right,
Then it will be our last part on the motor frame. We have our motor mount, which will be using threads to screw into the motor, and would then be
Wow.
once again radially bolted using 3 layers of screws.
Okay,
Then that
excellent.
will be our fin and motor.
Okay, nice motor.
Thank you very much.
I like it.
Yep, I think that would be like the whole rocket already.
Okay, so those threads at the front, those are what hold the motor in the rocket?
Yeah,
Okay,
and positional with them.
and what will that part your hand is on, what will that be fastened to?
Yeah, it will be fastened using the radio bolts, but this one is not what do you call it again? Punctured in because it's spare part.
Oh,
if like
okay,
you recall, yeah. But the real one we have like holes like this in them to be locked
okay. Yes, good, good. Lots of holes. I like it.
into
Okay, well, that looks very good. You've done remarkable work. It looks very sturdy. Looks like it would make a very stiff rocket too. Does it have very little flex? You know, when you put it all together, it's gonna be pretty sturdy and not wobble a lot.
Yeah, it will be pretty stiff. Yeah.
Yeah, good, good. Excellent. Can I look at the very aft end of the fin section?
Yep. Right. Right around. Oh, sorry.
Yeah, that's it. Good. I just want to see how pretty the fins are. They
Yeah,
are
this one.
beautiful.
Yep. You wanna-
Okay.
Okay, maybe this one too.
Yes, nice fillets.
Thank you very much.
Yeah.
Okay. Would you need any like better zoom ins on like the
I'm-
fins?
No, I'm fine. I just
Okay.
like to look at them. Yeah. Well, I think you've done everything I need. Is there anything else you'd like to fill me in on or that I should know or would like to
Yeah.
know? You'd like to
I want to ask about the second rocket planet shooting at
Oh,
the thing that we asked about in the
yes.
email. Yeah.
My apologies. I haven't asked about that yet, but I'll do that tonight and get back with you as soon as I can.
Oh, yeah. Okay. Sure.
Yeah.
Any other questions? Anybody? Teams? Nope. I think we have no more questions. It seems.
Excellent. Well, let me ask you, what is tomorrow's flight for?
It's just to get a better idea of our data, our flight path, and everything else. Yeah, and just like
Okay.
to confirm once more, like the recovery, ejection, everything. Yeah, basically.
Okay. Very good. Well, I'm glad you're doing that and I hope it goes well.
Thank you very much.
Yes.
Hopefully too.
Yes, indeed. Well, again, I thank you so much for being willing to do this again, and my apologies for making you do it, but it's all for the good of the order.
Yeah. Okay. It's our pleasure too.
Okay.
I think then
Yeah.
that's it.
Well, I'm fine with me. Ready for bye-bye?
Would you do you have any other questions? No.
I'm fine. You've answered them all.
Okay.
Yes. Well, thank
Thank
you
you.
again, and I'll see you in New Mexico, if not sooner.
Okay.
Bye-bye.
See you.
All right.
Bye-bye.
Bye-bye.
Everybody.
Take care.
Take care too.